All right, 7.3 dot product of two geometric vectors. The dot product is A dot B is equal to magnitude of A times the magnitude of B cosine theta. Theta is the angle between A and B when they are tail to tail. So in this case, we're not looking at a resultant vector. We're trying to calculate dot product. Dot product can only be calculated when you know the angle between the two vectors and the angle the two vectors are tail to tail. So the dot product is equal to this formula that you need to memorize. Some properties of the dot product include the following. A dot B is equal to B dot A. A dot A is equal to the magnitude of A all squared. Why is that the case? Well, if you think about A, vector A, and you dot A. Alright, so if we look at this vector A right here that you see here, and we do A dot A, vector A dot A means that we take the magnitude of A times the magnitude of A cosine of 0. Now if you remember, cosine of 0 is 1. So vector A dot vector A is equal to the magnitude of A all squared. Alright, next property. We have a scalar value k times vector A dot vector B. Well, we can remove that scalar value and attach it to B if we want. Or we can take out the scalar value completely and we're left with A dot B. So the beauty of that is that we can manipulate dot products in order to solve problems. The last one, vector A dot B plus C, is equal to A dot B plus A dot C. So the distributive property works even for dot products. Alright, so the next thing that we're looking for is an example. Example 1. Find A dot B, include a diagram. So we have three types of examples of this so that you could understand what we're looking at. We have vector A is equal to 3, vector B is equal to 5, so the magnitudes of those vectors, and the theta, which is the angle between A and vector B, is 35 degrees. So we have an acute angle. Well, we've calculated the dot product and we get a value of 12.2873 units. And a diagram, we have vector A and vector B tail to tail, and the angle is 35 degrees. So it's an acute angle. You'll have an answer that is positive. Now, dot product can also be negative when you have an obtuse angle, as shown here. This obtuse angle will result in a negative value for dot product. And again, it's tail to tail, vector A and vector B, and the angle between there is 130 degrees. Well, what about when they're 90 degrees? What happens to vector A and vector B? So we have vector A is 10, vector B is 11, there we go, it's 11, and we calculate the dot product of A dot B. This time, the theta is equal to 90 degrees, so they're exactly perpendicular. Well, in this case, remember that cosine of 90 is actually 0. So the dot product of two perpendicular vectors will be 0. That is always true, folks. So the dot product of any two perpendicular vectors will result in an answer of 0. A very important property to remember. Alright, let's look at the next problem. Example number 2. Given A plus 2B and 3A minus B are perpendicular, and vector A, the magnitude, is 1/2 the magnitude of B, we're asked to determine the angle between A and B. Alright, to do that, one important thing that we note here is that you're given two vectors are perpendicular. Well, we know that the dot product of perpendicular vectors is equal to 0. So we can expand this using the distributive property, or FOIL, and we get this result. Once we realize and simplify using some of the properties we know, we get these values. And don't forget to collect the like terms of the A dot B. Now, we know that vector the magnitude of A is half of the magnitude of B, so we can replace the magnitude of A with half of magnitude of B squared, plus 5A dot B minus 2 magnitude of B squared equals 0. So, what will you get? 5 times A dot B is equal to, and we can move the magnitude onto the other side. And this is what we get, because 3 times a quarter is 3/4, minus 2 is going to be 5/4, negative 5/4. But when we bring it to the other side, it becomes positive 5/4. Now what we're going to do is divide by 5 so that you get A dot B, which is also known as A dot B is the magnitude of A times the magnitude of B cos theta, and that equals 1/4 of the magnitude of B squared. Why is that the case, folks? Well, remember that we had to divide by 5. When we divide the 5 over here, that becomes 1/4. 1/4 of the magnitude of B squared. We need to find theta. To find theta, we divide both sides by magnitude of A times the magnitude of B, both sides. So what will that result in? Well, when we divide by the magnitude of A and magnitude of B, we get the magnitude of B's cancel, so we're left with magnitude of B over 4 times the magnitude of A. What will that result in? Well, we will have a value such that the magnitude of B is over 2 magnitude of B. Why is that the case? Well, let's look at this, folks. We know on the bottom, that's down here, 4 times the magnitude of A is equal to 4 times half of the magnitude of B. 4 times a half gives you 2, so that's where the 2 magnitude of B comes in. The B and the B's cancel, so you get a half. Cosine of theta is equal to half. That's a special angle. Theta, it turns out to be 60 degrees. So the angle between vector A and B is 60 degrees. All right, last example. Example number 3. Given the magnitude of x plus y is equal to the magnitude of x minus y, you're asked to prove x and y are perpendicular. Well, this is kind of tough. So we need to figure out what we do know. We know something special about magnitudes. We know that the magnitude squared means that the angle between the two values is 0. So, what we're going to do is actually take x plus y, magnitude of that, and square it. And make that equal to the other side, squared. What that means is that the angle between x plus y and x plus y is 0, and the magnitude of x minus y and x minus y is 0. Why are we doing this? Well, we can convert this back to another form. Magnitude of x plus y all squared is equal to x plus y dot x plus y. And the magnitude of x minus y all squared is equal to minus y dot x minus y. So what we will result in is we can expand this so that we have x dot x, which is magnitude of x squared, plus 2x dot y, plus magnitude of y all squared is equal to magnitude of x all squared minus 2x dot y plus magnitude of y squared. Well, how does that help us? Well, folks, we get 4x dot y, okay, is equal to 0. Because when we look here, this x squared will cancel with this x squared, so they're gone. This y squared will cancel with this y squared, so that's gone. And we can move this to the other side so that we get 4 times x dot y, collecting like terms. On the other side, there's going to be 0. Well, that means that x dot y is equal to 0. Well, the dot product is 0 of x and y. That means x and y have a 90-degree angle between them. So x dot y is perpendicular. And so again, the dot product is equal to 0. That means the angle between the two is 0. So we have proven that x dot and y are actually perpendicular. All right, that's the end of the video, folks. Take care. Have a good night.